time for part 7 of the Authentication miniseries. Hopefully this will be the last one. I am your host and future AI overlord, Vilo, and in this video we will wrap up SPA logins. In the previous video, after a week of effort, we finally completed the SPA login page for a React app. Even though we've done that, it cannot be said that we are done. The JWT tokens we are getting from Azure AD have a short expiration of about 30 to 60 minutes, so we are worried that the user might get locked out from the backend in the middle of his session. In that case, he should get a 401 challenge from the backend, as opposed to the incorrect 403 we are using now. After which the frontend should try to get a new token. Since that might involve a redirect, we will also need a way to store the client state in between. This is a great time to try out IndexedDB. In our last video, we were using session storage, which blocks the entire browser and isn't recommended for real use, so we should strive to do the right thing instead here. To summarize what our goals should be, that would be to make the logins reactive. Instead of having a login page at the start, we should have the user login only when that is necessary. Once we have that, we won't have to worry about token expirations specifically. Rather than try to eliminate a specific issue, we will design the application properly so that it cannot occur in the first place. The forbidden status code 403 is actually intended when a user is authenticated but can't access a part of the site due to insufficient credentials. 401 is intended for authentication failures. Let's start by changing that forbidden to challenge. Then we'll factor out the create proxy function. That by itself isn't a big deal, but for the sake of being able to replace the remoting proxy, what we will do is put it in a reference. That will give us the flexibility that we need to change it later. We'll ignore the type errors for now. If we scroll down here, we'll see what we need to factor out. Let's take it easy. The last video was such a mess because we were dealing with configurations, which in our opinion is amongst the most difficult of all programming tasks. The reason being that we were constantly dealing with unknown unknowns and had to try out things and take risks. So we had to plow through with effort. In contrast, what we are doing here now is straightforward engineering. In our attempt to factor out the token acquisition code, we are encountering a problem. Mentally, we were thinking of the redirect as if it had the any type, but it has the unit type. This is making us unsure whether the redirect acts as an exception or not. Does it execute the statements past the redirect or not? Instead of waffling like this, it would be better to just test it out. Then we can plan ahead. Let's test it out quickly. The best way to do that would be to make use of local storage. If we assume that redirect is doing what its unit type implies it should do, then saving into local storage, redirecting and saving again should result in 2 items. If it doesn't and acts like an exception, then only 1 item should remain in local storage after we get back to it. Here we are commenting out all the unnecessary parts and getting rid of the type errors. In the end, what we see is that only 1 item remains, it is acting like an exception. The redirect should really have a generic type like failwith instead of unit. Let's take advantage of this knowledge. For the login redirect, we can use unbox to convert the unit to any type. We'll factor out all the occurrences of PCI login redirect and unbox it there. This merely does type conversion, it won't have any runtime effect. We'll also pull the exception handling inside where it should be. We thought that pulling in the exception handler inside might get rid of the re-raise error, but it is persistent. Just why is it happening? It seems re-raise cannot be used inside computation expressions. In that case, what should we do? One thing we'd like to avoid if possible is to pass the exception into raise. The reason for that is because it would erase the stack trace. At least that would be the behavior on the .NET side. One thing we are curious about is whether just leaving the generic case out would lead to it being propagated or if we'd get a pattern miss. We don't really use exceptions that often in our programming practice, so we never had to try this before. And based on the results of these experiments, we can just leave the generic case out. The re-raise shouldn't bother us because we won't be re-raising at all. And come to think of it, we never got a compiler warning for not having generic cases in tries with. Also, this does indicate that we should be using try with instead of promise catch if we want to catch specific exceptions. Right now we are set. We'll factor out the utility functions we have made into their own module. And after some thinking, since JS is single-threaded, we think it would be fine to factor out the proxy into a global as well. We'll go into a time lapse here for a few minutes and implement our vision. Not bad. With this kind of setup, if the token expires, it will automatically try to get a fresh one after it gets a challenge from the backend. Let's refine our program a bit. Instead of using session storage, which is forcing a redirect login every time we open a new tab, what if we instead used local storage? We'd hoped that keeping the account info around for longer would make it easier to start the program, but as you can see, merely switching to local storage is not enough to avoid a redirect. Not only would a redirect be required on startup every time, but it would also be triggered once the token expires. A redirect is one thing, but having to type in our email and access code every time is too much. Let's go over the potential improvements one by one to see if we can do anything to make things easier. We'll start by modifying the prompt and move to seeing if keeping around the entire past authentication result would give us any advantages. The past authentication result has the ID token and the refresh tokens, in addition to the access token. Probably, they are there for a reason. Here we are looking through the authentication result, but we can't see anything in particular to pass into the config. But we do vaguely remember that there is a prompt field. No, it isn't in the silent config. Maybe it is in the redirect config instead? We'll quickly fix the type errors and then test it out. We think that the redirects should stop because of that prompt none we put in. But at this point, we'll have to go over it in the debugger. We are not sure what the control flow is at this point. Is that silent token even doing anything? Does the interactive request get triggered? We need to find that out. Before that, we've noticed that we accidentally erased the interactive request case. Let's put it back in. Then we'll make room for the breakpoints. Let's pause for a bit here, so we can review what just happened. We placed a bunch of breakpoints and realized that it was always doing a redirect. Since we had the prompt none, it got the token somehow without going to the Azure AD login page. We realized that we forgot to store the old authentication result, and after we fixed that, thanks to having the old token around, the redirects completely went away. If you go back and watch the URL bar after the fix was implemented, you'll see that it was not flashing for brief moments. As one last check, we want to see what happens when it does a silent token acquire. We'll disable returning the old token just so we can try out that path specifically. Based on the result of this experiment, we can see that we did needless work by storing the full authentication token instead of just the account info like we had previously. We'll revert that. After that, we will do something advanced just for the sake of learning. We could end this video here, but we won't. Even though we are set as far as this demo is concerned, let us highlight the try_proxy class once again. We implemented this like so. Because we are wrapping the API calls in the other file using this, it will have the effect of catching 401 errors for us. Since this toy API has 2 methods in total, doing this by hand is not a big deal. But it looks ugly in the code itself. Instead of writing to do API proxy run and then using a lambda to pass in the method name, we think it would be a lot better if that were to be done automatically. In a dynamic language like JavaScript, we just iterate over all the object fields and apply this wrapper function to it. Why couldn't we do the same in F#? No reason at all. We shouldn't be shy about using reflection when it would make the code a lot more clear, so let's give that a try. During this initial stage, we'll just take the time to get properly familiar with the F# reflection library. .NET reflection is a complex subject, and in our opinion a somewhat disgusting one, but if we restrict our attention to just the functional subset of it, we will have a much easier time doing something useful. Ignoring classes, F# has only 4 types worth mentioning: tuples, records, functions, and union types, and restricting our attention to just those will simplify things greatly. In our case, we need to get familiar with records. We need to know how to extract their fields, modify them, and then put them back together again. We'll do a couple of experiments, and then we will abstract out that Fable remoting proxy. Our struggling with clicking on things in the debugger aside, what we want to check out are the differences between .NET and Fable.js introspection. .NET is strongly typed, but over here, if we try constructing a record with an invalid type, it doesn't seem like we get any warning at all, let alone an exception. Take a look at how it constructed a record with an int instead of a function. In .NET, this would have been impossible. .NET's intermediate assembly language itself is strongly typed and would not have allowed this. Next, let's do a couple of experiments to verify how functions are called in Fable. We are concerned that we might need to handle the tuple case in a special manner. By that, we mean when the arguments passed into a function is a tuple. We want to make sure whether the behavior is different or the same when the types of the arguments are known at compile time. Is it always passing the tuple as a JavaScript array, or is it doing something smarter to avoid those potential allocations? Personally, we don't care about the performance, but we don't want to pass an in-tuple array when the function could potentially be using separate arguments. And now, not only have we made sure through experimentation, but as you can see, the way the function is compiled in JS makes use of tupled arguments. Wrapping that Fable remoting proxy will be the easiest thing in the world. It is good that we checked this last thing out. One of our alternative ideas was to set a timer to reacquire the token slightly before its expiration time, but that would have ended up with it being recycled and not doing what we wanted. Hopefully after the token expires for real, it will get reacquired silently instead of through a redirect. If we've been leading you down a false path, please correct us in the comments. We know this is a somewhat complicated solution, what with us using reflection, but it was a pretty good exercise. Despite programming in F# for well over half a decade, we've managed to avoid ever using reflection. .NET Reflection has a disgustingly complex design, but if you just focus on the functional part of it, you can get a lot of use for it in scenarios like these that require serialization without having to put too much effort into it. F#'s type system by itself is simply not strong enough to abstract the patterns that we saw, which is why we had to reach for this tool. Anyway, we'll end the video here. If you found this useful and want to help us in return, click those like and subscribe buttons. Thank you. We think we've been studying authentication for 3 weeks straight by now, which feels like too much time to be focusing on a boring subject like this. It really shouldn't have been this complicated, but it was. Now that we have the template, any future programs we do will be done much more quickly. We simply needed to do this. As aspiring web developers, imagine if a client asked us to make a web page and we spent 3 weeks implementing the login part of it? That would have been embarrassing. Next time on GhostLike's channel, we'll finish up the authentication miniseries by taking a look at IndexedDB and seeing how the local storage could be replaced using it. We've already made our SPA reactive, so we'll add the final bits of refinement to make our work perfect. Also, we didn't manage it this time, but we'll also want to figure out how we could make our proxy creation and wrapping functions generic. We'll investigate if we can do anything about the compiler errors we got last time. We just have a little bit more to go until we are done. See you in the next video.